So, alright, welcome to the lecture 15 session 1. And in this class, we are going to talk about something more about the classification, and we are going to see two techniques that are, one of them is called the KNN, very popularly called KNN classification algorithm. Another is a decision tree that actually have is one of the most, these are one of the most used um, machine learning methods. And then we would also see the random forest, and random forest is actually a technique that actually utilizes a decision tree, and therefore using the probabilistics methods give you an understanding that how can you we go beyond the um, capabilities of the decision tree. Sir, will we cover CNN and RNN in this course? No, CNN and RNN is not the subject matter of this course, but definitely into the machine learning course you may have gone through these concepts, but they are not here. So we are only here going to see about the KNN and decision tree. So let us start the class. All right. So okay, let me just. All right. So first question is this: that what is the classification? And you can explain this using this particular diagram. That here you see that there are multiple items. When you see that there are few items such as this particular grain and this particular grain, or this particular grain, this particular grain, or this black grain, they are similar. Similarly, you can find out multiple grains. So how many different kind of grains are there? You may have find out, do something and you come up that there are 10 different grains. Okay, so if you devise a technique so that you can, given a grain, you can tell that this which kind of grain it is. So we say that these are the labels that we assign to particular every item. Given a grain, you assign a label that it is gram, it is pulse. So given it is wheat, so given some item, you assign a label, and that particular label is coming from a predefined fixed set that you need to understand at this moment itself. What is the predefined fixed set? I told you that there are only 10 kind of grains available. So you note down those things, okay? And then whenever a new grain is given to you and ask that which kind of grain it is, you are going to pick one of the label from this set, because you know that only these 10 kind of things are there. Then you can say that this particular grain is of this type. Very simple example could be that if you go in a class in a school, say it is a high school, middle school, then you know that in a school only the students are studying into the class 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. So given a student, can you tell that which class it is? So yes, you can tell. So there are two things. That one, what is the predefined fixed set? Predefined fixed set contains the class 1, 2, 3, 4 to 12. These are the numbers. 1 to 12 is into the predefined fixed set. Now given a student, you want to give him a label. What would be the label? His class number. Alright. So this is the classification problem. To do the classification problem, how you proceed? With the particular item for which you want to find out the classification, you use some of the properties of that particular item to describe that what should be the label. Alright, and what could be those properties? In case of grain, you can use that what is the color of the grain, what is the texture of the grain, what is the weight of the grain, what is the density of the grain, how hard is the hardness of this grain, so on. So these things are properties. Based on these properties, you are going to tell me that which kind of grain it is. Okay, this is what the classification is. And all right, most of the cases, this predefined set that I talked about, predefined set of label only contains two items. Okay, and when it contains only two items, then we can take a liberty to say that one is of the class positive and another is the class of negative, because it looks easy. Okay, we can say that one is a class 0, another is a class 1. That is perfectly all right, because there are two classes. We are in the one class we are going to give a name, another class we are going to give the name. All right. So you should understand these terms. What we call by what is the feature, and what is the target class, and what is the label. Okay. Hmm? So you understand these things. So I want to tell you these 2-3 terms that are important, and those terms are what I'm going to tell you about those terms. What are those terms? One term is the feature. Okay, feature. What is a feature? Can you tell me what is the feature? Feature. One term is a feature. Feature. Given an item, you stack the feature. For example, given a grain, you see that what is the weight, what is the color, what is the texture. So these are the properties. Okay, so these properties are called features. Next is label. What is label? Label can be attached to a particular item. Label can be attached to the item. So you know that given an item, you extracted feature. Why it is not coming? Hmm? Given an item, you want to find out that what is the feature, and when the feature is actually going to represent you this particular thing, then you want to say that what is the, and you use this feature to say that what is the label here. Okay. Also, you should note down that this label is coming from a predefined fixed set. Yeah, predefined fixed, coming from predefined fixed set. It is coming from a predefined fixed set. All right. So this is what it is happening. So this you should note down. All right. So all right. So the first technique that we are going to see for the classification is the k nearest neighbor, and in abbreviated form, many other time we call it KNN. And actually it assumes, means if you have an assumption, it is your bias, that you are most likely as your friends. If you want to find out what kind of person he is, you find out what kind of people are surrounding him. If he is a, if he is a police officer, so police would be, more police officers would be his friend. If he is a farmer, more farmers would be his friend. Now this is the assumption is. There could be counter examples also. So this KNN algorithm is a two-step algorithm that if a new item comes and you want to find out what is the classification, then you have to find out its K friends. Friends means peoples who are near to him. How to say that two peoples are near? You extract their properties, such as what is the classification, what is the weight, what do they were, kind of thing, and then you try to find out what is the distance. If we can represent the person into the n-dimensional space as a point, then you can use the Euclidean distance between them. So you can find out the distance. Okay. So you first, if you find out the distance, then you can sort all the other points based on the distance and pick the top k out of them, and then you apply the majority voting. Okay. So let me give an example. It's a lazy learner, means when the data item are given, it does not create anything, and when the question is asked, then only it try to solve the problem. Okay. So let me just go to the example so that it becomes clear to you. So you see that these are the examples where I specify that k is equal to 3. Okay, and these are the positive, these are the red class, and some points are there are green class, red and green class. The new point is coming. Okay, this is blue point. So can you, what should be the classification for this item? Is it red or green? Can anybody tell? Hmm? Red or green? What should I assign? Can you tell me? I'm not getting any answer. Any class I can assign, na? Alright. So the first thing would be I have to find out 3 nearest other points, okay, because they are friends. So how to define the friends? They are nearer points. Other nearer points are friends. So however, this friend is very far away, it's not very near, but these are the friends. These could only be the candidate for the friend. Alright, okay. So if these are the friends, then now I think you can tell that what should be the class for this particular item. Can you give me the class? Red. Alright, the class should be red. Alright. Okay, let me give another point. What is the class for this item? Green, because you see that the 3 nearest friends are now, they are not, earlier they were far apart, but now this time they are not that far apart, and you see that they are 3 and all of them are green, then the classification is going to be green. Okay, what about this point? This is the new point. Can you tell me what is the classification for this item? Red. Alright, let us see. So you see that, sir, can I assume density is deciding it? Yes, I told you, na, this particular thing is actually initially you have to find out the k items. K is here 3 items, which are the nearest. Out of all the items, you are going to find out the k nearest item. So here you see that these are the only first 3 nearest item, and then you see that what is their classification and apply a majority voting. Apply a majority voting 2 step. First step, search for the k other data points, most difficult part, and then applying the majority voting. Okay. So this way you see that the classification you know. Can you tell me what the classification for this item is? You see that this is the thing, therefore you say the green. Now you would agree with me, number 1, that to avoid the ties you should use the k equal to only odd numbers. If it is an even number, it may be possible that a 2 green, 2 red, then you would be into the problem. So you should use this k number should be an odd number, it should not be an even number, so that every time there you can decide that what should be the class, number 1. And the another thing is that k is sensitive to the noise, because if the data has a noise, to see this point would be very easily can go here and there, and therefore new point can come here. If the data has a noise, means data locations are not, can be altered, then in that case you see that there is a problem. It may be possible the classification can change. So the biggest problem with this case nearest neighbor is that it is sensitive to the noise, and it has a high bias. What is a high bias? What is the bias? First line I have written, the bias is that you are most likely as your friend, but it may not be the true in all the cases, na? So this is what the bias it applies. So once again, k nearest neighbor is an algorithm that is a 2-step process. In first step you find out k nearest data points, and in the second step you apply a majority voting. So finding majority voting is not a difficult part, because for the given data item you know that what is the class, so therefore you can just see the set and tell that this is the class. But finding out the k nearest point is actually difficult. Why? How much time it would take? Can you tell me? How much time it would take if you given the data? I say that give me the k nearest point. Okay, how much time it would take? Order of k into n. Order of k n. Why? Order of k n. Why? Can you understand this? Order of because when you want to find out the nearest point, you have to search for all the items. Okay, and then you would find out that this is the smallest item, and then you have to do again another iteration to find out that which is the second smallest item. Then you have to again go ahead and find out who is the third nearest point, and therefore 3 iterations are possible. If all the data items are given, you have to do 3 iterations. Are you with me? Somebody is asking how to choose the value of k. That comes from the bias, because by your understanding you tell that these many number of items should be there. So this comes from your bias, okay, and somebody tells you that this should be the number. But my point is that k should be odd. So I was discussing that if say 100 numbers are given to you and you have to find out for a new item that which is the nearest item, so you have to compare with all these items. So how many comparison is needed? 300 comparison. Are you with me? To find out the minimum item, you have to do 300, nearly 300 computations, because you first search for that item and you find out that this is a minimum item, you delete that item, then you again search for the minimum item, delete that item, search for the minimum item, delete that item, put it somewhere else, and now you put it again, so that nothing is lost. Nobody is telling me that I'm telling wrong. I'm telling the right thing or wrong thing. How to find out the 3 nearest neighbors? Is it the right way? Nobody is telling. Tell me that no, it's not right way. All right, very good. This is not the right way. Actually, if you find out, if you want to find the smallest and the largest number, then you need not to go for the 2 iterations. Only in single iteration it is possible. All right. And similarly, if you want to find out the first highest, second highest, and third highest, then also you need not to go for the complete. Then also you need not to go the complete searching of the things. Only single means multiple number of iterations. Only single iteration would suffice. Then also single iteration suffices. All right. I would not go into the detail, but you can search for the algorithm that how you can simultaneously find out k smallest item. But the point is, most of the time your data set is of the large size, and therefore finding out this k items is not that easy as it looks like. It is going to take a lot of time. All right. So therefore, this is the most difficult part, because your data is assumed, data size is assumed to be large, and therefore finding out that particular item, that who are the 3 items who are nearer, it becomes very difficult. So therefore, this algorithm requires a special kind of data structures that are location sensitive, and therefore given the item, they can very easily do is some hashing kind of thing and tell that these items are nearer to you. So this is the actually extra information that is not given over here, but you should keep in mind that if you want to apply the KNN, the biggest hurdle is going to be the number of data items into the training database, and therefore you have to apply a special kind of databases so that you can quickly identify the nearest neighbors. Clear? All right, this algorithm is clear. Okay, so we would go to the another algorithm now. This algorithm is called the decision tree algorithm. Okay, and this looks like this, that if you are in at this particular place, it looks like a tree, and you check what is the outlook. If outlook is sunny, then you go to this branch. Let's assume that outlook can take only 3 values: sunny, overcast, and rain. So if outlook is overcast, you say yes. What is meaning of yes? Let's assume I am asking that whether you are going to play badminton or not. So if it is if outlook is overcast, then you say that I'm going to play the badminton. If outlook is rain, then you go for the see that how the wind it is, and then based on the wind you see that whether if wind is strong you say no, when it is weak you say yes. So kind of this thing. Okay, each branch here, each node specifies a test condition, and therefore each branch actually says that what that condition means, and you go ahead until you find out the decision. So it's a kind of thing. You say that outlook is equal to sunny and humidity is equal to normal and outlook. You say that if you want to represent this thing in a single line, you can say that when the things are yes, 3 cases, 1, 2, 3. And what is this? Outlook is equal to overcast. What is this? Outlook is equal to sunny, humidity is equal to normal. What is this? Yes, outlook is equal to rain and wind is equal to weak. So you say that if this or this or this, then you say yes, otherwise you say no. All right. So this is a decision tree thing, and in today's class we would be seeing that given the data how you can create the decision tree. Okay. Instances are represented by attribute value pairs. Okay. The decision tree is applicable when the stresses are represented by attribute value pair. Target function has discrete output values. This is a very important thing because every attribute should be discrete. Then only you can apply. If it is not discrete, then you have to discretize it using some methods. So we will talk about that later. Okay, when disjunctive description is required and the training data may contain missing and errors, and this is a very big thing because this particular kind of classification algorithm can handle missing values even if you are not specifying all the things, but it can give you the right classification. So this is very important. Okay, so now we want to talk about a very important mathematical quantity. Sir, if I exchange the node of dt with lack of knowledge, sir, what if I exchange the node of decision tree with a lack of knowledge? Now, what do you want to ask? If you change the outlook with wind, then look. What do you mean by lack of knowledge? I don't know. Okay, so we are going to see. Look, we are going to talk about that how to build the decision tree. Okay, in the class. So you would be wait for a few minutes. We will be talking about this. So before going to that, I want to introduce one more concept that is called entropy. Entropy tells that how much pure use database is. Okay, it characterizes the impurity of an arbitrary collection of example. If your data is very impure, then we say the entropy is high. Entropy is a measure of disorderness. If lot of things, how can I say that it is very impure? First of all, we are only considering our discussion with respect to the classification where only two classes are there, positive and negative, 0 and 1, yes or no. Only two classes are there. So only two classes are there. So what maximum, how can you make it pure? Everything is yes. Everything is no is also a pure thing. But if you want to mix something, so how would you do? You put some yes, some no. So when it would what would be the point when it would be the maximum there impurity? When you say when there is a 50% of yes and 50% of the no. Okay, इससे ज़्यादा तो impurity नहीं होगा, otherwise it would start becoming pure. Okay. All right. So entropy is the measure of disorderness, and this is the formula actually. It tells that for I is equal to 1 to C the classes. How many classes we have? Two classes we have. Probability of that particular class into log of the probability of that particular class. Okay, so this is the formula, probability of class into probability of that class, and for every class you write this formula. So what does it mean? That how many classes we have? We have two classes. How many classes? Two classes. Okay, what are the classes? There is some problem. Okay, the class is yes and the class is no, two class. For this class you have to find out this particular value, minus pi log of twice. So you have to find out what is the probability of class yes and what is the probability of class no, and then you find out py log of py, and then also you find out probability of no log of probability of no. You subtract these, take the negative of these things, and you find out the addition. This is what it is. For every class you find out this thing. Okay, the value that you get by this equation is into the range 0 and 1, and that means entropy minimum value is 0 and maximum value is 1. It is 0 when all the members are of the same class. Means I am telling that it is the measure of disorderedness. So if everything is of the same class, then there is no disorderedness. And when the maximum disorderedness is there, when equal number of positive and negative classes are there. So this is how this graph actually, entropy graph looks like. So it is maximum value is at the 1 when probability of a particular class is 0.5. If the probability of one class becomes 1, so other class becomes 0. So it becomes 0, the entropy becomes 0. Otherwise you see all these values, and the probability of this class becomes 0, the other class becomes 1. So again it is a pure thing and therefore there is no disorderness. So this is kind of thing. Now we are going to see this using an example. I need your support at this particular moment. Can you compute with me? Can you find out, sir, what do we mean by impurity of the data? Impurity of the data, I told you in this class that if everything is positive, it's a pure data. If everything is negative, it's a pure data. But let's assume everything is positive. I put one negative example. Now it is impure. In everything positive, two negative, more impurity. So how can I increase the impurity? Keep putting negative items. Impurity is getting introduced, and you remove the positive ones. At the end, what would happen? Everything would become uh, negative and no positive. Again, it becomes pure. Okay. So this is kind of thing. Purity means, I mean that single class. Now I want to find out that if this is the data, and what is this data? 14 data items are given to you, and they pertain about the day conditions. One day could be you want to measure what is the outlook, what is the temperature, what is the humidity, what is the wind. And let's assume that you only consider the identify that outlook could be sunny, overcast, or rainy. Temperature could be hot, mild, or cold. Humidity could be high or normal. Wind could be weak or strong. Alright, so these things are possible. So and day and on that day, if whether you go for the play or not. So this sunny, hot, high, weak, you don't go for the play. On this day also you don't go for the play. So if this is the data, so you understand the data. Everybody can write yes that you understand the data. Everybody can you write yes that you understand the data? Huh? Nobody is writing yes. Only one yes. Alright, I'm happy that you understand the data. Now my simple question is, can you tell me what is the probability of yes? How many classes we have? Can you tell me how many classes are there? How many classes are there? Two classes. Yes or no? Because this is what the classification is, na? Whether you are going to play or not. This is the classification. How many classes? Two classes. Alright. So for every class I have to find out what is the probability. So can you tell me that what is the probability of yes? What is the probability of yes? I'm not telling anything. I'm just asking the question. Somebody is telling 9 by 14. Okay, all right. The 14 examples are there. I'm asking the probability of a yes. Count how many yes are there. 1, 2, 3, 4. Sorry, there are 9 yes. 9 yes are there. So therefore the probability is 9 by 14. How many no's are there? What is the probability of no? So right answer is 9 by 14. How many no's are there? 1, 2, 3, 4, 5. Therefore probability of no is 5 by 14. All right. So if you know these values, so can you put into the formula? Okay. Entropy, we want to find out the entropy for the 9 positive and 5 negative. And therefore the equation comes out to be 9 by 14 log 2. Base is always 2. Okay. 9 by 14 and 5 by 14 log 5 by 14. Can you see this formula? Do you understand this? You understand this formula? This came for this. Is it clear? Yes? Alright. Let's go ahead. So therefore if you find out the computation, it comes out to be 0.94. So can you verify by your calculator, because I have asked you to bring the calculator. Can you verify? Can anybody verify that it is 0.94? No? Alright. So believe on me. By yourself you can verify this. The answer comes out to be 0.94. This is what the entropy is. Okay, alright. So this is what it is, that you saw that the entropy comes out to be 0.94. Okay. Now I want to tell you a new thing that is called the information gain. Information gain. Information gain of an attribute A. Attribute kya hai? What do you mean by attribute? Okay, so let me tell you that in this table, in this data, outlook is an attribute, temperature is an attribute, humidity is an attribute, wind is an attribute. All these things are attribute. All right. So information gain of an attribute A. A means what? You assign A could be outlook, temperature, humidity, or wind. Is the expected reduction of the entropy caused by partitioning the data set yes according to that attribute. What is S? S is the data set. Now, data set, this S contains data set. So if what is the data set? Data set contains these 14 example. Data set S is equal to D1, D2, D3, D14 because these 14 items we have. So all right. So I would be I know that what is the data set, and I want to find out that what is the information gain of the attribute, and the information gain of what is the information gain of outlook, what is the information gain of temperature, what is information gain of humidity and wind. How to find out this thing? This is the formula, and let us closely look this particular formula. This formula says that you find out entropy of ES. What is ES? Actual database. The actual database contains these 14 examples. And can you tell me what is the entropy of S? Can anybody tell me what is the entropy of S? Okay, can you tell me what is the entropy of S? So since I told you that S is this database, so therefore entropy is 0.94, है ना? Because we have computed this. What is the what value we have computed? Entropy we have computed as pen has some problem. 0.94. So you understand this? This is the entropy. And now we want to find out what is this. Okay, this is a very interesting thing, and it actually says that let's see that what is A. Okay, so and we know that what could be A outlook. Let's assume the A is outlook. So let me say that A is outlook. Okay, let me take the A is equal to outlook. Let me take A is equal to outlook. O U T L double O. Okay, let's assume that this is outlook. So for outlook, this particular thing we know that because entropy of S is a fixed thing, but this part we want to find out what is the value. So it says that what is value of A? Value of A, and A we know A is outlook. So what is the value of A? Value of A, value of outlook. Value of outlook means what are the all values possible. So can you see this? Sunny, overcast and rainy. Overcast, sunny, rainy, these things. So sunny, overcast and rainy. Only 3 values are possible. Alright, so you say that it could be sunny, overcast or rainy. R-A-I-N. I just write like this, okay? So for every, since it is a summation, for every value, so you have to find out this particular formula. What is the formula? That SV means if you divide the thing based on that, how many items are there? Okay, and then you see that what is the mod of, means mod says that what is the cardinality of this item. So initially you see that what is the cardinality of the S and how many items are there. Okay, so let us see that whether do I have something on the board. All right. So we know that this was the database. And for example, if we want to find out as sunny, if you use sunny, so you say how many data items are there with respect to the sunny. So this data item 1, data item 2, and data item 8, data item 9, and data item 11. So as sunny means how many data item? 1, 2, 8, 9, and 11. Okay. So we actually wanted here to find out this, and this actually give me just give me 1 minute. I'm just pausing. Alright, looks like there is a problem with the writer at this moment, so therefore I would take a break at this moment, and into the next session maybe after it is 7:40 at my side, and we would be starting at 7:55. Okay, after 15 minutes we would be starting. Alright, So in this till this point now we have talked about that what is entropy. Given a database, how can you find out what is the entropy? And in this particular slide we are focusing that how to find out the information gain, and this is the formula. We have discussed something, but to complete the complete discussion would follow into the second session. Okay, thank you very much. Thank you for being into the session. Just see this formula. Into the next session I will be explaining, that is going to start around 7:55. All right.